Hey, you're on.
Alright, well...
Evolution.
Where to start? So let's just start with the basics. Basically, what evolution states, and it's very simple, it's a very simple concept, is that when there is a genetic mutation in a species, if that genetic mutation gives a positive result to a species, then that'll obviously spread through the community because if it increases their chances of survival, then obviously they get more chances to breed and spread their genome across the species, right? So, yeah, I mean, that's evolution in the most basic sense, is that when a mutation occurs, that person will go on, and if it is positive, then they'll spread that mutation, that advantage throughout the species, and that changes them for the better. And this happens across, all species. Evolution is really just a concept used to define the term.
So is evolution a theory or is it a law?
Okay, I'm just going to go straight out right now. It's a fact. People say, oh, well, it's a theory. It's not a theory. Number one, no missing link. Number two, we've observed evolution in micro scales. The only thing to debate is whether or not there's macro scales, but you'd be ridiculous to think that there isn't in macro scales, since we all start off as, a sperm cell and an egg cell, and there are mutations that happen all the time. In fact, I believe, I could be wrong, so don't quote me on this, but I believe the statistic is that 1 in every 10,000 cells has a mutation. And, there's a lot of sperm cells that are produced daily, and, but you get the point, right?
Right.
So it's
so the big debate is, do we come from chimpanzees or monkeys? Did we evolve from that? And actually, we could even say we evolved before even that, because before there were monkeys and apes.
What? Yeah, I mean, we came from chimps. I mean, you can deny it if you want, but 98% genetic similarity between us and chimps is...
98.5, actually.
Sorry, 98.5% is a ridiculous thing to argue, right? It's like, it's about as dumb as arguing as dogs didn't come from wolves, right? So...
Yeah, I think that's at a 95%.
Oh, that's a 99.5% genetic similarity.
Between wolves. I was looking at a cat one where they said that the average, cats that we have at home, pet cat, and let's say a tiger or a lion is 95.7 or something like that. So it was almost 96%.
Right.
And nobody's denying that they're not from the same species.
Right. Plus, you look at it, we have the fossil transitions to show that we came from chimps, right?
So explain that, because a lot of people, they think like, one day it was a monkey and then one day a monkey gave birth to a full human being.
Well, okay, so basically the way we know that we came from chimps is that we look at the mitochondrial DNA, because mitochondria in your cells, they're the organelles that produce energy for your body. They make ATP and such. And basically, their DNA changes very little over generations. So while the cell's overall DNA might change, the mitochondrial DNA is kind of like a textbook, and it holds all the information, right? So basically what we did was we looked at the DNA, and we saw the similarities. So we started looking at different fossils, right? We started looking for the evidence. And, of course, you've heard of Lucy.
Yes.
Which is, the first bipedal ancestor, which was 3.2 million years ago. So you can actually track, Lucy back to our
bipedal means that they walk
on two legs, right? You can trace her back to chimpanzees, and then you can also trace her forward to modern-day humans.
Right.
So that's evolution. I mean, there's no real debate about it. It's ridiculous to think that it doesn't happen, because we observe it happen. We see, viruses change. We see microorganisms evolve. We see it constantly, and we even have proof.
Okay, but so here's the big argument. If there are human beings and we came from monkeys, why are there still monkeys?
Well, there's two ways to look at that, okay? So number one, obviously, there's the easiest way to explain it in 5 seconds, which is, well, there are different species of chimps. So if one species evolves, that's different from an entire group evolving, right? So you may have one species of chimp evolve, but not the entire, family of chimps. And then there's the other way to look at it, which is, if you have two groups of chimps, here, let's even simplify this further. Let's say you have two groups of cells, and they're all the same species, right? And there's yellow and blue food. Now, these organisms, these cells split off into two groups. And one group goes west and one group goes east, right? So they can only eat yellow food. But one day, the groups run out of yellow food. So the group in the east, who developed the ability to not only eat yellow food, but also blue food, is going to survive, and the group in the west isn't. So these split off into two different groups, and they split off into two different species because of different environmental needs. So that's basically what happened, right? When you have two groups separate, and then they need different evolutionary mechanisms to sustain themselves and live and sustain their species, they can split off into different groups. And that's how evolution works.
Oh, all right. Well, thank you for that insight.
Yeah, no problem.